Hello, you are most welcome. I'm teacher Ivan from Wuuna Educational Services. I welcome you to our second part of O-level physics calculations on forces. In the first part, we looked at the three cases of getting resultant force acting on a body. And therefore, in this second part, we shall be looking at how we apply the knowledge we acquired in the first part. So, we shall be using the examples to see how we apply the knowledge we acquired in the first lesson. Our example 1 tells us that forces act on a body as shown below. We have three forces acting on the same body, that is the 250 newtons and the 70 newtons plus the 90 newtons. These two are acting in the same direction, and therefore from the first case we saw that when two forces are acting in the same direction, we add them, and therefore that will give us the resultant in that direction as 160 newtons. And therefore we shall be remaining with the two forces which are acting on the same body but in opposite directions. And now that brings us to case 2, where we saw that when forces are acting on the body in opposite directions, the resultant is obtained by subtracting the bigger minus the smaller force. And therefore, the resultant on the body will be given by 250 newtons, take away the 160 newtons, which gives us 90 newtons. But we must be also interested in knowing which force will take the body. It is definitely 250. Then by how much? It will take by 90, meaning that the 90 newtons will be in the direction of the 250 newtons. So we shall conclude that the resultant force acting on the body is 90 newtons in the direction of the 250 newtons. And we shall simply illustrate that by drawing that single force on our diagram to show the resultant or the final force acting on the body. Then this is our second example, where we have still forces acting on a body as shown below. And in this particular example, we have still three forces acting on the same body. But the two forces on the same side are not in the same direction. So you must always take a note of the arrows, because the arrows are the ones that tell us the direction of the force. So these two are opposite because they are in opposite directions. And when you look at the 40 newtons, is in the direction of the 30 newtons, meaning when getting the resultant, we shall first add the 30 newtons to 40 newtons because they are in the same direction. And therefore, that will give us another structure of forces, whereby here we shall have 90 newtons, and this side we shall add the 30 plus the 40 to give us 70 newtons. And now these two are in opposite directions. So the resultant will be now given by, remember, if they are in opposite directions, we subtract the bigger, take away the smaller, which is 90 newtons, take away the 70 newtons. And that gives us the final answer as 20 newtons. But in which direction? Remember, 90 is taking the body by 20. And therefore, if we are to illustrate that, we shall illustrate it that way, whereby 90 takes this body by 20, meaning that the impact of 20 is the same impact as 90 and 70 on this body. So that is our second example. We have our third example, which shows two forces of 8 and 6 newtons act on a body at right angles. They want us to find the resultant force. Don't forget that our third case in lesson 1 showed us that when we have forces, two forces acting on the same body at right angles, the resultant will be given from the formula resultant force equaling to the square root of force 1 squared plus force 2 squared, assuming this one is force 1 and this is force 2. That is how we shall get the resultant force. This was derived from the Pythagoras theorem, a method that shows us how we solve right-angled triangles, because the resultant will be probably in that direction. This is where our resultant force will be acting. And therefore, when we connect to form a right-angled triangle, the vertical is F1, the horizontal is F2. So to get the longest side, we get the square root of F1 plus, or F1 plus F2, they are squares. So that is how we get the resultant force when forces are acting at right angles on the same body. And therefore, it is just a matter of substituting. It doesn't matter which one is the 8 newtons, which one is the 6 newtons. It can be 8 here, 6 there, or 6 here, 8 here. It doesn't change our answer. And therefore, the resultant will be given by the square root of 8 squared plus 6 squared, which gives us the square root of 64 plus 36, which is the square root of 100, hence giving us 10 newtons as the resultant force. We may be interested in knowing the direction. The direction is given by direction of resultant force, Fr. This one is given from the Sokato. That is tan theta, where theta is the direction, gives us the vertical component over the horizontal component. Remember, our vertical component is F1 and horizontal component is F2. Now, I'm taking this to be 8, I'm taking this to be 6. Meaning that tan theta is given by Fy, the vertical component, which is 8 in this case, over Fx, the horizontal component, which is 6. So that will be 8 over 6. And now theta will be the arctan of 8 over 6. So once you get the arctan, how do we get arctan? Place shift on your calculator, then turn. Open bracket, write 8 over 6, close brackets, press equals. That gives us the direction. And that direction is always to the horizontal, as you're moving from the horizontal going to the vertical component. So that is how we shall get the resultant force in the case of forces acting on a right angle to the body. Then we also have another example. In this example, we are told that 4 forces act on a body of mass 260 grams, as shown below. These are the 4 forces. And now the question is, calculate part A, the resultant force, part B, acceleration, and part C, the direction. Now, let us look at how we get the resultant force. These are our 4 forces, but we shall first of all consider forces that are acting on the body horizontally and those that are acting on the body vertically. So we can even say horizontal resultant force. The horizontal resultant force is given as, remember, we take bigger minus smaller. So that will be 12 newtons, take away 7 newtons, which gives us 5 newtons. But this 5 newton will be in the direction of the bigger force, which is 12. Then similarly, we shall get the resultant vertical, whereby we are now considering 14 newtons, take away the 2 newtons. So that gives us the vertical resultant force. Please don't write abbreviations, that is not allowed. I'm just using it because it is a lesson, but as you are answering your assignments and exams, we don't know this. So please don't write those abbreviations. So let's come back. We are saying that we are considering the vertical forces of 14 and 2. But we shall take 14, take away 2. So that gives us the vertical resultant force as 14 newtons, take away 2 newtons, which give us 12 newtons. And now we shall have another new arrangement of forces acting on the body. That is, in the direction of 14, we are remaining with 12 because we took away the 2, which was downward. Then, even on this side of 12, we are remaining with 5 newtons. Remember, I told you that we shall take bigger minus smaller, but the resultant is in the direction of the bigger. The same applies to this, meaning that the resultant will be upward, the resultant will be on our right. So that is how we do it. And then we come up with this new arrangement whereby these ones will be acting at a right angle. So we shall have our final resultant force as the square root of 12 squared plus 5 squared. Hence giving us, when you compute this, you get 13 newtons. That will be our resultant force. The other part was asking for calculating the acceleration. From the formula, which is force equals to mass times acceleration. Remember, in the question we are given the mass of the body as 260 grams. And now we have the force. So it's a matter of just substituting. Where there is force, we use 13. Where there is mass, it was 260, but it was grams. However, it should be expressed in kilograms, which is the SI unit of mass. Therefore, we divide by 1,000 to express mass in kilograms times acceleration due to gravity. So that gives us 13 equaling it to, we can reduce that to 0.26a, where a is our acceleration. Therefore, we shall divide by 0.26 by 0.26, and we shall have our acceleration in meters per second squared. That is how we get the acceleration of the body. For direction, we've seen how we get direction. We shall say tan theta, assuming this is our direction for the resultant. So this is our theta, meaning that it is making an angle theta with the horizontal, which is 5. So that angle is what gives us the direction. Tan theta equals to 12 over 5. Remember, tan is opposite over adjacent. And when we come back to our diagram, the vertical is 12, the horizontal is 5. So it is opposite over adjacent. That's why we have 12 over 5. And therefore, our angle will be the arctan of 12 over 5. When we get the angle, we shall say the resultant force of 13 newtons makes an angle which we shall get with the 5 newtons. That's how we shall get the direction of the resultant force. Otherwise, I'm teacher Ivan from Wunna Educational Services. But before we leave, it is very important that you also get some numbers for your own practice. So with me are 2 numbers which I want you to also try out. That is our first number. It is asking for resultant force and acceleration of the body if the mass is 750 grams. Then we have number 2 that also has 3 forces acting on the same body, and they want us to get the resultant force and the direction. So those are the 2 numbers I want you to try out. Please, you can pause and copy them, try them, so that you also evaluate how much have you acquired from this lesson. Otherwise, I'm teacher Ivan from Wuuna Educational Services. Don't forget to subscribe and hit the bell.